Done. It's finally done, and I can present to you the CR-10 Smart X. And this is the culmination of a lot of work. Everything from PCB design to 3D modeling, measuring, prototyping, reverse engineering, configuring firmware, developing slicer profiles, making wiring diagrams, and finally all of the filming and editing of this video. I've finally fixed the CR-10 Smart with the intention of putting in all of the work up front so that you guys can replicate this project as pain-free and as easily as possible. And that also includes CR-6 SE owners, because these two machines share so much in common. When the CR-10 Smart first came out, I did a review on this printer, and after months of using it, I gave it a pretty fair review. However, months after that, I started to experience first layer inconsistency problems, which led to a ton of failed prints. Now, this printer does not have bed leveling knobs, so there's no way to adjust the print bed. It relies super heavily on the auto bed leveling system. Now, from the factory, it comes with a strain gauge probe on the nozzle, and in theory, this sounds like a good idea, but in practice, it didn't work out so well in the end, and I determined that it was the root cause of my problems. Now, since then, Creality has moved on to using the CR Touch as a standard probe on their printers, and there's probably a reason for that. Now, for you guys who own the CR-10 Smart or the CR-6 SE, over time, your printer may have turned into a giant paperweight, until now. This video covers a huge array of new upgrades for this machine, including some new features on the print head. So we got a 5015 part cooling fan with dual part cooling fan ducts. We have a new mount for the hot end because of course we're getting rid of the original strain gauge probe. We've got a mount for the CR Touch, and inside of the machine we have the Easy Swap PCB kit, which I designed, that's gonna allow us to upgrade to the SKR Mini E3 V3. And that's of course because we're going to the CR Touch, and the original main board on the CR-10 Smart and the CR-6 SE is not compatible with the CR Touch. I'm also gonna show you guys how to install a touch screen, as well as these NeoPixel LEDs and a power control relay. Now, those Easy Swap PCBs that I just mentioned are intended to make this whole upgrade experience as simple as possible on the CR-10 Smart and the CR-6 SE. And in this video, I'm doing the full suite of modifications, but shortly, I'm gonna be releasing another video that's briefly gonna go over the use of those PCBs and the different directions that you can go in if you don't wanna do all these modifications and you wanna just save some money and do some simple upgrades. On top of that, I'm gonna come out with a third video showing this entire process on the CR-6 SE using the exact same PCBs. And that's because the electronics of these two printers are functionally identical. And so if you're not new to upgrading your 3D printer and you have a CR-6 SE, you could watch this video and pretty much apply the exact same concepts to that printer and do all of the same modifications before I even release that video. And so with all of that said, let's get started. The very first thing we're gonna look at is the print head, and you'll notice that my CR-10 Smart still has my original LGX direct drive kit on there with the Micro Swiss hot end. Now, this needs to be upgraded to the latest and greatest, which is going to have the mount for the CR Touch, and it's going to get rid of the strain gauge. So we need to remove this fan shroud on the front, and there are two M3 bolts on the front and then one on the back. Once you remove those, the fan shroud will pop right off, and beneath that there will be two more M3 screws holding the hot end fan on. There are two additional M3 screws holding the fan duct on, and then you'll find four M2.5 screws securing the part cooling fan in place on the right hand side of the hot end. We can then remove the silicone boot and start loosening off the set screws on the heater block that would hold the heater cartridge and the thermistor in place. To the left of the hot end, there's a small bracket that acts as a strain relief for the heater cartridge and thermistor wires, so you need to remove that as well. And then you can pull those two elements out of the heater block. Up at the top of the hot end, there are two M3 button head cap screws holding that entire hot end to the strain gauge sensor. Then you can remove the strain gauge sensor itself with another two M3 button head cap screws holding it to the X carriage bracket. To the right of that, there's one more bracket being held in place with another two M3 button head cap screws, and you can completely remove that and you've stripped down your entire hot end. Now we can take a look at the new assembly that I designed, and the first thing that probably stands out is the CR Touch on the left hand side, and of course that's going to replace the strain gauge sensor. And then you see this big red fan duct and a 5015 part cooling fan. So we're going to be upgrading from a 4010 fan to this much larger 5015 fan with dual fan ducts down at the bottom, so this should provide much better part cooling. In the 3D model, it was pictured in red, but in real life, I've printed it in black carbon fiber PETG, and the print came out beautiful. And you can expect that same quality from me if you order this part through my website, embracemaking.com. Now we can take a look at how I'm getting this 24 volt 5015 fan installed into that fan duct. And what we need to do here is we need to pop the top cover off of it. And you can do that with your fingernails or a flathead screwdriver. There's just a few clips around the body of the plastic housing, and it'll just completely clip apart. Now we can take the bottom half with all of its guts, and it'll just slip right into this fan duct. And then we're going to be taking 2 of these M4 socket head cap screws, and they'll thread directly into the 3D printed part. Next up is the bracket that holds the hot end in place, and this is going to replace the original strain gauge, as well as provide a mount for the new CR Touch. As you guys can see, I'm using the Micro Swiss all metal hot end, but if you don't need an all metal hot end and you want to save some money, you can use a regular CR-6 SE hot end, but you just can't use the original CR-10 Smart hot end. So you can see I've bolted it in through the top. Another 2 of the M3x10 socket head cap screws secure that in place, and then we can start unpackaging the CR Touch, and it comes with a few M3 screws as well. You can use the M3x6 button head cap screws to attach the CR Touch to this bracket. They'll thread in from the bottom, and just pay attention to the orientation of the CR Touch probe. It should be facing in the direction such that when you look at it from the top, the connector at the top is completely accessible. If it's not, you'll have to flip it around. Now we can mount this subassembly to the X gantry, and that's going to be done using some existing holes in this metal plate, and we're going to be using more M3x6 button head cap screws to do this. You can reuse these fasteners from the previous assembly, or you can use the new ones that I've included in these kits. This first fastener that I'm working on here is tucked into a bit of a tight spot, so if you have a ball end Allen wrench, that's going to make your life a lot easier. There's a total of 3 of these fasteners, and they are all the same length. Once we get those snugged down, we're going to move on to the heater cartridge and thermistor, and in order to get those in, we're going to have to loosen off the set screw on the front of the hot end to rotate the heater block to gain better access to the holes on the side of the heater block to slide in the thermistor and heater cartridge. If you have thermal paste, I would recommend using it on those components, and then you can retighten the set screw at the front of the hot end, and you can tighten the set screws at the bottom of the heater block to lock those parts in place, and then we can put the silicone sock back on. Now we can get our fan shroud in place, and we're going to use 3 screws to do that. The 2 at the front here are M3x6, and the one sort of off to the back is an M3x8, and these are all going to be button head cap screws. As always, do not over tighten these screws, just remember that you're working with plastic parts here. Next, we can get the hot end fan installed in the front, and that can be secured down with M3x12 socket head cap screws. You can use all 4 holes if you want, but I'm going to use just 2 of them, and that's more than enough to secure a small fan like that. And now we can plug in the wiring harness that comes with the CR Touch probe. Now we have all the wires coming off of the print head, so we can loop a zip tie through the strain relief, and we can start to mock up what our wire management is going to look like in the end. This isn't going to be final, but it's just going to get things organized so we can determine the lengths of the wires that we're going to use. Since we're no longer using the original strain gauge sensor, we're going to remove the PCB that used to control its output signal. It's located on the gantry under a plastic cover, and you're going to need to use a flathead screwdriver to pop that plastic cover off, and then you can remove the ribbon cables going to that PCB. It's a tight space to work within, so if you have big fingers, you might want to use another flathead screwdriver and carefully pry off all of the connectors on this PCB. If you've never been in there before, they might also be held on with a little bit of hot glue from the factory, so you're going to have to remove that hot glue, and you might have to cut away some zip ties holding the wiring harness in there. Once you have everything disconnected, you can remove the plastic cover, and then the PCB will be exposed, and you'll see 4 M3 button head cap screws that you can remove, and that entire PCB will come right off. Now this next part here is completely optional, and it's only if you want to run some RGBW NeoPixels. That part can be downloaded on my printables page, check the video description. To install it, we need to remove the auxiliary PCB mount, and then we can access 3 more screws that were hiding behind it. And again, these are all M3 button head cap screws, and you can see where they're located. Having a cool electric screwdriver like this makes quick work of these small fasteners on 3D printers, and if you're looking for one of those, check the video description for a link to that as well. Once we have the cover off, we're going to strip away some of these parts because we need to reuse the X limit switch on the new cover. It's held on with 2 small screws. I believe they are M2.5 screws. Once they're removed, the X limit switch will come right off, and then we can tackle the 2 LEDs, and I believe these are held on with M3 screws. The wires are bundled together on these 2 parts, and so once you remove both parts, you can take that wiring harness off, and then we're going to pull the LEDs out because we're not going to be reusing those, and all I'm interested in here is reusing the X limit switch and its connector. Pulling those connectors through the wire sheathing is a little easier if you de-pin them, and you can use a razor blade or other sharp tool to do that, and once that's done, they'll pull through pretty easily. Then we need to wire in the new NeoPixel LEDs, and to do that, I'm going to be using this 3-pin JST XH connector. I designed the cover around these NeoPixel jewel boards, and they have 7 LEDs on them, and that fits within the current limitation of the SKR Mini without having to add on an additional power module. I've soldered the 3 wires to the NeoPixel board from the JST connector, and the pinout can be found available on the wiring diagram that I've provided on my website. To mount the NeoPixels inside of the cover, I would suggest using some M2x6 thread forming screws, and these will bite right into the plastic and they'll securely mount those NeoPixel jewels. To mount the X limit switch, you can reuse the original fasteners, or you can move to more thread forming screws. If you go to the thread forming screws, you're going to have to find something about 12 millimeters in length or slightly longer to bite into the plastic cover. And if you reuse the original screws, it's going to depend on your printer tolerance whether or not they're going to bite into that plastic, or they might be too loose. You might have to adjust the hole size in the model that I've provided. Then we need to bundle those wires together, and we can tie them to the side of the cover using a zip tie. Now, the reason for that is that inside of this cover is normally where the drive pulley goes for the X-axis. And so I'm showing you this 3D model so you can visualize what's going on inside of the cover, and you can see where the wires are going to get tucked up into that side of the cover to stay away from the belt. And this 3D printed cover installs back onto the gantry the same way that the old cover came back off with those 3 screws. And once you have it on, just run your print head over and make sure that the X carriage is still making contact with the X limit switch. Now we can put the PCB holder back in place, and we can take a look at the new auxiliary PCB. And so as I mentioned earlier, because we're replacing the strain gauge sensor, we no longer need the PCB that comes with the CR-10 Smart. It used to have a circuit on there that controls the output signal for the strain gauge sensor, but my new PCB is a complete drop-in replacement, and it's going to break out all the connections for your print head, and it's going to provide us with a NeoPixel connector as well as a connector for an auto bed leveling sensor like the CR Touch. And because it is a drop-in replacement, we can start remaking all of our connections using the original wiring harnesses and connectors, and we won't have to repin any of them. They're completely pin compatible with all of those original connectors. One thing you might notice is that there are 2 connectors for the heating element on the hot end. Now this doesn't mean you can plug in 2 heating elements. You can only plug in 1, but I wanted to give you the option of using a JST connector if your heating element came with one of those, or you can use these screw terminals if your heating element came with ferrules. Then we can plug in our original ribbon cables, which makes this entire wiring process so much easier. To cover that PCB and provide strain relief to the wiring harness, I've designed this new cover, and it comes in 2 pieces, and those 2 pieces screw together with M3x6 screws. You can use either regular machine screws or these thread forming screws, and they work really well inside of plastic. That cover will just slip over top of the wiring harness and snap into place using the original snap fit little connectors, just the same way that the original cover did. If you have any excess wire, there's a pretty generous amount of space in there that you can bundle up that excess inside of the cover, just like you see I did here with the extruder wires. I'm going to reconnect my filament runaway detection sensor, and then I can use the circular strain relief feature and a zip tie to hold the harness in place. And what you'll notice is that I have a couple other zip ties behind the red one, and that's going to prevent any of those connections from pulling out. Moving on to the main control board, you're going to carefully flip your printer onto its side and remove the bottom cover. there is a cooling fan attached to this cover, which has a wire and connector attached to the main board, so be careful not to just rip the cover right off. Now you should be able to see all of the original electronics, and we're going to be removing pretty much everything here. And if you've never poked around underneath your printer before, a lot of these connectors are just JST connectors and they'll simply unplug from the receptacle, but some of them might still have hot glue on them, so have to remove the hot glue before you can start unplugging everything. And although we're not going to be reusing any of these electronic control boards, we will try and reuse a lot of the harness and the connectors, so be as careful as possible and try not to damage any of the connectors. And this is especially true for these large ribbon cables here. They are specific to the CR-10 Smart, and we're going to be reusing them, and it's going to make our lives a lot easier when it comes to rewiring this machine. If you've never done this before, another tip here is to just take your time and stay organized. All of these connections that you're removing, take an extra second and have a look at the PCB and see if there's labels on the PCB so you know what it is that you're disconnecting, or take a look at the wires themselves and see if they've been labeled. Many of the wires have little yellow labels on them that will say things like X, Y, and Z, and those are going to correspond with the X, Y, and Z axes. If they have 4 wires, those are usually for motors, and if they have 2 wires, those are usually for the end stops. And if you don't find any labels, you can make your own with a piece of tape and a Sharpie. And once you get all the connectors off, to remove the PCBs, oftentimes they're held to the enclosure with M3 button head cap screws. So you're really only going to need one tool to do this. And if you take a look at what I'm doing now, once the main control board is removed from the enclosure, there might be one more connection that's a little tough to get at without removing the board first, and that is for the original touchscreen. After that, we can remove a few more wires and connectors that we're no longer going to be using, and this is going to declutter and tidy up the bottom of our enclosure. 2 of these harnesses are connected to the USB port and Ethernet port on the side of the machine. In order to get those free, there are more M3 screws holding those connectors to the faceplate, and the faceplate itself may actually have to be partially removed in order to get that Ethernet cable out. So again, more M3 button head cap screws on the side. Just loosen them off, lift the plate up, and you should be able to wiggle out that Ethernet cable. And again, this is not necessary to do, but it will make the finished product look a lot cleaner and a lot nicer once you're done. Now you can cut away any other zip ties holding wires down, because we are going to be routing these connectors to new positions in the bottom of the enclosure, and of course we need them to reach. Now that we've created a bunch of empty space in our enclosure, we can install the mounting adapter for the SKR Mini. And this adapter has a split in one of the holes, and that split's going to get lined up with the standoff with that brass insert in there, so you can see the orientation. And now to install this adapter, we're going to be using M3x6 button head cap screws. Now that one standoff in the left hand corner, that one is going to get a washer underneath, and the rest of them do not need any washers. To install the SKR Mini to the adapter, you have a few different options in terms of hardware. You can tap those holes for M3 threads, or you can use these M3 thread forming screws. And I really like these fasteners because they cut their own threads into the plastic and they never really come out. Once you've installed all of the screws, the first connections that we're going to make are for the heated bed. I've carefully positioned the SKR Mini so that all of the original connectors and wires will reach, and you should not have to extend any of them. However, the one thing that I would recommend that you do is any of these wires that go into these screw terminals that have stripped ends, I would cut those off because they've been tinned from the factory, and I would switch over to using proper ferrule connection. The tinned ends are known to come loose over time, and that can be a fire hazard. So I would highly recommend moving to ferruled connections. They're way safer. Also, the heated bed connections are pretty easy to identify as they're coming from a cable that is grounded to the case. At this point, another easy connection to make is the 24-volt power going to the main board. These are the same wires that supplied the original main board with 24 volts from the power supply, and I'm doing the same thing here where I'm cutting the tinned ends off and I'm replacing them with wire ferrules. And if you trace these wires back, what you'll find is 2 more black and red wires that were originally powering one of the other PCBs that we removed. At this point, these are redundant, and if we don't have the ends terminated, we don't want live wires just sitting around in our enclosure, so we're going to remove those 2 wires. They can easily be removed by loosening off the Phillips head screws on the power supply and just removing the spade connectors. Above the power supply, I'm going to be replacing the original Creality relay with the Big Tree Tech relay version 1.2. This part is completely optional, and you could just wire your power supply directly to the main switch at the back of the printer, but I want to show you guys how to use this module. Before removing this relay, I'm going to mark the 2 wires that are labeled live in, and just keep in mind here that on this side of the relay, we're working with AC voltage. Be sure that your printer is completely unplugged from your wall receptacle. You don't want to be touching live AC wires with your fingers or tools. Now, I designed a mounting bracket for the new relay, and it attaches to the enclosure by slipping over the original mounting studs, and you're going to use M3x6 button head cap screws to secure this thing down. Then you can free up some of those wires by prying out these wire retainers that slip inside of the extrusion that the frame is made out of. They're just a press fit into the extrusion channel, so you can typically remove them with a flathead screwdriver without much effort. The relay itself gets attached to the mounting adapter using more of those M3x6 or 8 thread forming screws. Once the relay is mounted, we can start making some of our connections on the AC side of the relay. Similar to the power supply and the original relay, it just uses these Phillips head screws to hold down these spade terminals. The terminals are clearly labeled on the new relay, and we can reuse the original wires and connectors. And this is why I had suggested marking the original connectors so they're easy to identify later. I'm going to tuck some of these wires up into the extrusion channel and reuse some of those wire retainers that I had removed earlier. By moving these wires into the extrusion channels, there's just less of a chance of these wires getting accidentally pulled on or damaged in the future. And if you want to use this relay, the one wire that you will have to modify is the neutral wire. And on a Creality CR-10 Smart, this is the black wire going into the main switch. If for some reason you have different colored wires under your printer, you can always trace them back to the power supply where you'll find the labels live, neutral, and ground. I cut off the original female spade terminal, and I used a crimped splice connector to make a Y. When working with these AC voltages, it's better to use mechanical crimps than it is to solder wires, so if you have a crimping tool, definitely go with a mechanical crimp. One end of the Y connector goes to the neutral terminal on the relay, and the other one goes to the main switch. Then we can remove the wires going to the original momentary push button, and I've created a new set of connectors here that have the female spade terminals that will go to the push button, and then they have DuPont connectors that go to the Big Tree Tech relay. This will allow the button to trigger the relay to reset, and there's no polarity on these wires. The new relay came with some of these wires that have 2-pin JST connectors on either end. One of them is going to get plugged into that middle connector on the relay, and the other one's going to get plugged into the PS connector on the main board. Using the other included wire, we're going to make a connection between the power detection plug on the relay to the power detection plug on the main board. Except for on the main board, this one has a 3-pin connector. Luckily, the original relay came with a JST XH 3-pin connector, and so all we need to do here is de-pin this 1 pin from the original connector, and we can plug in the 2 new pins from the new connector. There are lots of good videos online on how to repin JST connectors. It's quick and easy, so you can take a look for those on YouTube. And with that done, we can plug in our Z stepper motors into the receptacles at the bottom of the SKR Mini, and there's 2 Z motor plugs. And now we can have a quick look at the breakout board that's going to make the rest of our wiring very simple and very easy. And this one here is a prototype, so it might look slightly different than the version that I'm going to release. But what you'll notice here are a bunch of receptacles, some of which have been populated, some of which have not. Most of them are spring terminals, some of them are screw terminals, and then of course the headers for the original ribbon cables. It's comparable in size to the original Wi-Fi board, so it should fit nicely inside of the enclosure. And again, I've designed it so that it makes minimal work in terms of making the final connections to the main board. The final version should look something more like this, but again, the general concept of making all these connections will be the same, and I'm going to make a specific video explaining all of the different use cases for this board for both the CR-10 Smart and the CR-6 SE, so keep an eye out for that video in the future. For now, I'll demonstrate the installation with the prototype board, and again, this PCB has an adapter that we're going to install over top of the original standoffs. And then a couple of those screws are going to be shared with the original standoffs, and those are going to be M3x6 button head cap screws. And in the top right hand corner, I have a single M3 thread forming screw. Now you'll find that the original ribbon cables plug directly into those headers, and the purpose here is to break out all of the connections from the print head. Now the one other special connector here is this 6-pin connector for the Y-axis. Creality combined the Y motor and Y end stop into one 6-pin connector. On my Breakout board, I elected to go with a screw terminal for the heater cartridge connection to the main board, and this is because those screw terminals typically carry more current than the spring terminals. The other connection is just a 2-pin connector for the hot end thermistor. Below that, I've got two 3-pin connections. One of them is for the NeoPixels and the other one is for the filament runout detection sensor, and both of those go to corresponding ports on the main board. This black, red, and yellow cable actually came from the original wiring of this printer, and the one end already had a JST connector on there, and the other end I just stripped off the ends of those wires to go into the spring terminals. This is why earlier I said to save your wiring, because a lot of it can be reused. For any new cable that you have to make with a JST connector on the end, you have a few options if you don't want to invest in a high-cost specialty tool. In the past, I made a video showing how to do this with a low-cost generic tool, and your other option is to go on Amazon and get yourself a JST kit with pre-terminated wires. Check the video description for a link to those, and just a friendly reminder, again, on my website I have a very detailed documentation of all of the wiring for this printer, so you can see each of the individual connections and where they go. You'll also find a link to that article in the video description as well. Back to the wiring, we're going to tackle the next 3 connectors. First, we have the X motor, which runs from this 4-pin spring terminal over to the 4-pin JST connector on the main board. Below that, we have the part cooling fan, and that runs up to the fan 0 connector on the main board. And then below that one, we have the hot end fan, and that one goes up to the fan 1 connector on the main board. On the Breakout board, both of these fans share a common positive voltage trace, and so that means the supply voltage on both the part cooling fan and the hot end fan will be the same. And again, you can find all of these notes in the detailed wiring diagrams. Next up, we're going to do the extruder wires here. So the extruder motor is a 4-wire connection. Again, 4 wires coming off of the 4-pin spring terminal into the 4-pin JST connector on the main board. And then below that, we have the X end stop. And just keep in mind here again that this is the prototype board, so you'll see JST connectors on these end stops, when in reality on the final version there will be more spring terminals. And this also goes for this next end stop that I just pointed to, and that is the Y end stop. What you also may notice here is that I'm bundling and organizing some of my wires using these Velcro tie wraps. These won't cut through unprotected wires like regular zip ties, and they come in these very convenient rolls. I'll put a link to those in the video description as well. And for those of you who are very observant will notice that a 5-pin spring terminal just appeared out of nowhere. Somehow I managed to forget to solder that onto the prototype board earlier, so it's back on there now, and that's for the auto bed leveling sensor. The pinout for that will be in the exact same order as any Creality CR Touch auto bed leveling sensor. I've also routed an SD card extension from the SD card reader to the outside of the case, and at least for the purposes of firmware updates, later on I'll find out that it's completely useless, so don't even bother doing that yourself. Lastly, you'll see that I've made the 2 connections for the TFT touchscreen. I'll be using the BTT TFT35 V3 touchscreen, and it comes with this ribbon cable with the IDC box connector on the end, and then the second cable with all of the black wires goes to the TFT header on the main board. This is a 5-pin connector with the 5th pin being loose, and so that loose 5th pin is on the far right hand side of this header. Down and to the left of this connector, you'll see a little red jumper. Make sure it's in this position here if you're not using an external DC to DC power module for the NeoPixel. So that's a very quick wiring walkthrough for using the SKR Mini with my Easy Swap Breakout board on the CR-10 Smart. I also used the optional BTT Tech relay, which I showed you guys how to wire that up as well. And another reminder, if you guys are looking for the detailed wiring diagrams, please visit my website. I'll put a link in the video description down below. Now you should be able to put the bottom cover back on your printer, and just remember to connect your board cooling fan to the fan 2 receptacle on the main board, and then you can screw it all back together. Just a moment ago, I mentioned that I'm using the BTT Tech TFT35 V3 touchscreen, And I have done the work for you in this area as well, and I've designed an enclosure that will mount to the front of the CR-10 Smart, and it'll mount the exact same mounting points as the original touchscreen. Getting the Creality touchscreen to work with the aftermarket board seemed like it was more trouble than it was worth, so I went with this one. And pay attention to which one I've chosen, because Big Tree Tech has a few touchscreens that look very similar. This one comes with 3 cables, 2 of the gray ribbon cables and 1 of the black cables, and I already explained where they plug into on the main board. The original touchscreen just pops right off the CR-10 Smart frame, and I've routed the new wires through the same hole that the original wires went through, and you can see that I've taken the back half of the 3D printed case for the TFT35 and snapped it in place using the same connection points as the original touchscreen. I only need to make 2 connections on the back of this touchscreen, so I've got the gray ribbon cable and I've connected it to expansion port 3, and then I've got the black cable with the JST connector on that, and that goes to the TFT connection. I'll carefully fold up the excess wire behind the screen, and then I'll get it tucked into place. The 3D printed front bezel goes directly on top, and you can see where the holes will line up. I'm going to use these M3x8 thread forming screws to secure the front bezel on. Then we can press fit the original rotary knob back on, and if you're wondering why there's a rotary knob on a touchscreen, that's because it's a dual mode screen. Then you can head over to my GitHub page, link in the video description, and this is where you'll find the screen firmware that I've configured for the Big Tree Tech TFT35 V3. Find yourself a cleanly formatted 8GB SD card and make sure that there are only 3 of these files in the root directory of the SD card. There will be the TFT35 folder, there'll be a .bin file, and there's the config.ini file. Insert the SD card into the touchscreen SD card slot at the left-hand side of the screen, and then we're going to power on the printer. Now, one thing we have to do if you've installed the Big Tree Tech Relay, and because we've not yet updated the mainboard firmware, we turn the printer on at the back and we must hold down the button on the side and continue holding it down for the duration of the firmware update. Do not let go of that button. If you let go of that button, the relay is not getting the proper signal from the mainboard to remain on until we update the mainboard firmware. Now that we've finished the firmware update on the touchscreen, we need to tackle the mainboard. And on my GitHub page, there's a repository for the CR-10 Smart for the SKR Mini, and there's a .bin file in the main folder. If you have the exact same setup that I do, you can use that .bin file and put it right on the SD card and flash it to your SKR Mini. If you're using any different equipment, for example, you're not using the LGX Lite extruder or maybe not the Big Tree Tech Relay, then you're gonna have to download the rest of the Marlin files and you're gonna have to compile your own Marlin configuration. There are a lot of great videos on YouTube on how to do this, and you can use my Marlin directory as a starting point. Ultimately, the goal here is to end up with a single .bin file that you can put on the SD card and then take that SD card and put it into your SKR Mini. Similar to the process on the touchscreen, you'll insert the SD card, power the printer on, and you'll just hold down that side button until the firmware is updated. It's a much faster process on the mainboard and only takes about 15 seconds or so. With all of the firmware ready to go, we can now finally set up our printer. And the very first thing that I like to do is get into the PID Auto Tune for the hot end. On this touchscreen, it's located in Menu, then Settings, then Machine, then Tuning. In the bottom left-hand corner, you can see that I've got it set to the nozzle. I'm going to click on the temperature, enter the temperature that I want to center the tuning around, and then I can hit Start. The PID process will start and the nozzle will begin heating up. And this is where I really like having those NeoPixel LEDs visible on the gantry because they are linked to events on the printer. In this case, they'll change from a purplish color to red when the nozzle is heating up, and when the whole process is complete, those event LEDs will turn green, and it's very obvious that this process is finished. Then you can click the icon in the bottom left-hand corner and it'll switch over to the bed, and you can do the same thing, entering the temperature on the bed that you want to center your tuning around. In this case, I've chosen 60 degrees because that's pretty common for PLA. Now, if you don't have the NeoPixels on the gantry, you can find that green light tucked in on the touchscreen behind the rotary knob. Those LEDs will perform the same function, but they're just much less visible. With the PID auto tuning done, you can press the heated bed icon on the main screen, set the temperature to 60 degrees, and this is going to preheat the print bed because now we're going to run the auto bed leveling and also set the Z offset. It's always best practice to do this with the print bed hot. Now, after homing all of the axes, you can go into Menu, Movement, and then Bed Level, and you'll notice that it says that BL is off, and that's the bed leveling, auto bed leveling is off. And that's because we have not yet run the auto bed leveling procedure to save a mesh. So if you head back into Move, then we can take the printer down to the Z0 position. And so right now in the top right hand corner of the screen, you can see how it says Z10. Also in the top right hand corner of the screen, you can see that the increments were set to 10 millimeters. So I just pressed the Z down button, and that's going to take the printer down to Z0. Then back in the bed leveling menu, you can see that there's a button for the Z probe offset. You're going to click that, and then you can jog your Z axis by different increments. I would suggest taking your time and moving the printer down by small increments. You're going to grab a piece of paper, you're going to put it underneath the nozzle, and you're going to continue to move the Z axis down until you get that slight drag on the piece of paper. In my case, I had to move the nozzle down an additional 1.3 millimeters, and then I could hit next and I could save that value to the EEPROM. Then back in the auto bed leveling menu, I can press ABL and we can just hit start. I've configured the firmware to measure 25 points across the print bed to generate the bed mesh. And this mesh is what the printer is going to use to make adjustments to the first layer of your print so that you get a perfect first layer every single time. And once the probing is done, back in the auto bed leveling menu, you'll notice now that it says BL is on. On the main screen, now I've pressed the nozzle icon and I'm going to preheat the nozzle to 220 degrees because we're ready to load in some filament. On the LGX Lite, you're just going to make sure that the toggle switch is flipped over to the left-hand side to release all the tension, and you can simply just push the filament down and through, and this is going to prime the nozzle. And once I'm satisfied with the purge, I'll flip the toggle to the first position and push the guide tube back down. After all of that, we're finally ready to run the first print. Slicing files is outside of the scope of this video, but what I will do is provide you with a Prusa Slicer profile for this printer, and I'll put that on my website, link in the video description below. Now this first print isn't going to be anything very exciting. I've opted to go with the regular 20mm calibration cube just to see how this thing is working. And right out of the gate with pretty much no tuning, the cube actually looks pretty good. The first layer went down nice and smooth, the walls look nice as well, the corners are reasonably sharp, they could be a little bit better. I might get into tuning for linear advance a little bit later, but the top layer is quite nice as well, and everything is looking pretty good for a first print. Based on the cube and a few other calibration prints, I made some adjustments to the slicer profile and I got into even more prints. This time, something a little more interesting. This time it's going to be a pattern of parts that's going to take up more of the print bed. And if you're noticing that while you're laying down that first layer, you need to make some adjustments to the Z offset, you can do that on the touchscreen while the printer is printing live. I find that this is pretty normal as part of the regular printer setup and tuning process. And for now, I'm running all of these prints using regular PLA Plus from eSun, and so far I'm very happy with how these first initial prints are turning out. With the SKR Mini running those TMC 2209 drivers, I've noticed the printer is extremely quiet and all the print moves are extremely smooth. Now before making all of these upgrades, when the CR-10 Smart actually worked, it did pump out some pretty nice looking parts, but it does seem that having the direct drive, the all-metal hot end, and now the upgraded mainboard, the prints are looking even better and it's taking this machine to the next level. But the best part of all of this is those first layers. It would seem that the new mainboard combined with the CR Touch probe has completely resolved those inconsistent first layers that I was experiencing with the previous strain gauge probe. I haven't even yet installed a PEI flex plate on this machine, and I've had zero first layer adhesion issues so far. And for those of you who already own a CR-10 Smart, you know this is a really big deal because this printer does not come with bed leveling knobs. Therefore, if your auto bed leveling system is not working flawlessly, you are going to have a really bad time trying to get those first layers to go down. And from what I can tell so far, I've now taken this machine from being a giant paperweight into being a high quality printing workhorse. I can now just press print on this printer and walk away and come back to very nice looking parts. And you can see here that I'm printing in Polyterra PLA Charcoal Black, And when you take a look at those layer lines, you can barely see them in this matte black material. All of the time and effort that I put into this printer has finally paid off, and I've tried to make this whole process as easy as possible for you guys to replicate as well. I'll likely spend a little more time further refining these print profiles, but as of right now, it's working great. And because those first layers are going down so nice and consistent, that consistency carries up through all of the other layers, and even things like support material pulls off the main part so easily and so cleanly, it just looks flawless. The print tolerances are also coming out excellent, and you can see in this time-lapse video that I'm printing a newly designed Deluxe spool holder. It features printed threads that are obviously functional, and I had absolutely no issues getting these two parts to fit together when printing on this machine. I also printed the twist lock spool holder mount that twists and locks itself into the Creality spool holder receptacle. Getting these parts to interface properly requires a fair bit of accuracy on the printer's behalf, and I had zero issues obtaining that accuracy with the new CR-10 Smart X. A while back, I designed a different Creality smooth spool holder that turned out to be quite popular. This new design that I'm dubbing the Super Deluxe model takes the original concept up a notch and provides even smoother motion, and best of all, you don't have to modify your original spool holder. On the CR-10 Smart with the direct drive, I put the spool holder in this position, which I've yet to see anyone else do, but I think it actually works pretty great with this Deluxe spool holder that you can find on my website, and the filament path is super smooth without any restriction whatsoever. So that concludes this video. Be sure to check out the video description where you're going to find all of the links for the resources for this project to do all of these upgrades for yourself. Also, don't forget to check out my website, embracemaking.com, where you'll find the PCBs for this project, as well as many other 3D printer upgrades. And please subscribe to my channel so that you guys don't miss the upcoming video on the CR-6 SE and more future content. Thanks for watching.